In the universe, there are primarily two categories of black holes, but a mystery has long puzzled astronomers. The existence of stellar and supermassive black holes is well documented, but definitive evidence for a third category, intermediate mass black holes, remains elusive. These mysterious objects could hold the key to solving a significant cosmological enigma, explaining the evolutionary process that leads to the formation of supermassive black holes, some of the most enigmatic objects in the universe. Black holes are regions of space characterized by incredibly high density and a gravitational force so intense that they warp space-time. Their gravitational pull is so strong that not only light but anything crossing the event horizon, the boundary beyond which nothing can escape, is inevitably drawn toward their center. The popular definition of black holes as regions from which nothing can escape, not even light, is partially correct. But the reality is more complex. In fact, it is not the speed of light that defines the boundary, but the immense curvature of space that prevents any object from escaping, regardless of its velocity. Another crucial aspect to understand is that black holes are not merely theoretical curiosities. Astronomers have developed sophisticated methods to study them indirectly, by observing the effects these gravitational objects have on surrounding stars and material. Stellar black holes form as a result of the death of massive stars, those with at least 3 times the mass of the Sun. When such a star exhausts its nuclear fuel, it can no longer counteract gravity. The result is a catastrophic collapse of the stellar core, giving rise to a supernova, a violent explosion that disperses much of the star's material, while the dense core collapses into itself to form a black hole. These black holes range from 3 to dozens of solar masses and are scattered throughout the universe. A recent example is the black hole BH3, with a mass of 33 suns, discovered in 2024 about 2,000 light-years from Earth, making it the most massive observed in our galaxy. Supermassive black holes, however, are colossal and located at the centers of galaxies. Their masses range from 100,000 to hundreds of billions of times the mass of the Sun. They play a significant role in the dynamics of their host galaxies, but their origin remains under study. The black hole at the center of our galaxy, Sagittarius A, has a mass of approximately 4.3 million solar masses. While the exact formation mechanism is unclear, astronomers suggest that stellar black holes may merge and grow over billions of years to become supermassive. For some time, astronomers have hypothesized that between stellar and supermassive black holes, there should exist an intermediate category, with masses ranging from 100 to 100,000 suns. These intermediate mass black holes could provide critical insight into how supermassive black holes form and grow over time. Yet, despite numerous efforts, astronomers have not found definitive evidence of their existence. While stellar and supermassive black holes have been observed using various techniques, intermediate mass black holes remain undetected. Why? The difficulty lies in the fact that, like all black holes, intermediate mass ones emit no light. However, astronomers have discovered black holes by studying their gravitational effects, particularly by observing stars orbiting these invisible objects, or material being drawn in and heated to extreme temperatures, forming an accretion disk. Even though black holes emit no light, there are several methods to identify them. One main technique is observing stars in binary systems, where a star orbits a black hole. The motion of the star can reveal the gravitational influence of the otherwise invisible black hole. A historical example of this technique is the discovery of Cygnus X1, the first identified stellar black hole with a mass of 21 suns, orbiting a blue supergiant star. Another method involves observing a star that comes too close to a black hole. When this happens, the black hole can strip away part of the star's matter, forming a glowing accretion disk observable with telescopes. Additionally, gravitational waves emitted during the merger of two stellar black holes can be detected by interferometers like LIGO and Virgo, offering another tool for studying black holes. In 2024, tangible evidence for the existence of intermediate mass black holes finally emerged. A major discovery was made in the globular cluster Omega Centauri, the largest star cluster in our galaxy. Using data from the Hubble Space Telescope, astronomers observed the motion of over 500 stars and noticed that those closest to the cluster's center were moving at speeds suggesting the presence of a massive, compact object with a mass of at least 21,000 solar masses. This object was identified as an intermediate mass black hole. The James Webb Telescope has made significant contributions to understanding black hole formation. Observations of a distant galaxy, Z1, revealed the presence of a supermassive black hole with about 40 million solar masses, despite the galaxy's young age, formed just 470 million years after the Big Bang. This finding raises questions about the time required for such massive black holes to form. One hypothesis is that the black hole in Z1 may have formed from the direct collapse of a giant primordial gas cloud, bypassing intermediate stellar stages. Recent observations are finally bridging the gap in our understanding of intermediate mass black holes. These mysterious objects could explain how supermassive black holes grow by accreting stellar black holes. Yet despite the progress, much remains to be discovered. Ongoing observations with telescopes like James Webb and Hubble promise to unveil new details about these fascinating objects and their role in the evolution of galaxies and the universe. Thank you for watching. Leave a like, subscribe to the channel, and activate the notification bell so you don't miss future videos.